This is a contest for individual high school students, not teams. Your teacher will register your school, and your bridge will be submitted to that teacher, who will deliver the bridge to Brookhaven Lab on a specified date. The object of this contest is to design, construct, and test the most efficient bridge built in accordance with the specifications. Model bridges are intended to be simplified versions of real-world bridges, which are designed to accept a load at any position and permit the load to travel across the entire bridge. In order to simplify the model bridge design process, the number of loading positions is reduced, and to allow the contest to proceed in a reasonable amount of time, only one loading position is tested. These simplifications do not negate the requirement that the bridge must be designed to accept a load at any of these specified positions. Bridges determined by the judges to not meet this requirement will be disqualified and tested, if possible, as exhibition bridges. Each year, the International Bridge Contest, run by the Chicago Institute of Technology, releases new bridge specifications sometime in the fall. This year, Brookhaven National Lab will hold the high school bridge contest independent of the International Bridge Contest. The Chicago Institute of Technology expects to resume the international contest again in 2022. Engineers from Brookhaven National Lab chose specifications from a past contest and modified the requirements for testing from above. Note, for future contests, your bridge must be able to be tested both from above at BNL and from below at the international contest. An inspection report is drawn up that summarizes all of the criteria that will be tested at the qualifications. These design criteria match the specifications exactly and will be measured using gauges that have been machined to their maximum and minimum measurements for each of the criteria. At each of the judging stations, a BNL engineer will inspect a certain part of the bridge and mark either qualified or disqualified in that section of the inspection sheet. Teachers will drop off their students' bridges at BNL. We provide an inspection sheet that will move through the qualification process with the bridge. To make this as easy as possible, make sure that your bridge has your name and bridge registration number written clearly on the side of the bridge, near the bottom. Please note that the measurements referred to in the next sections of this video are based on the 2021 bridge specifications and are subject to change each year. Always review the current bridge specifications before building your bridge. The first stop in the qualification process is where an engineer will weigh and record the mass of the bridge, while also checking that it is made with no more than 30 grams of 3 32 inch basswood that has not been painted or coated in any way. The next engineer checks that the bridge can span a gap of 300 millimeters, but is no longer than 400 millimeters, is no taller than 180 millimeters above the support surfaces, and has a width between 40 millimeters and 70 millimeters. This engineer also checks that no part of the bridge extends below the support surface that the bridge sits on during testing. Then, the bridge moves to the next station, where an engineer checks that the horizontal loading plane is a maximum height of 80 millimeters above the support surfaces. The load will be applied downward from above by means of a 40 millimeter square plate with a rod threaded into its center. The load plane is where the loading plate will sit. This can be the top of your bridge, but it does not have to be. There can be structures above the load plane, as long as they allow the load plate to fit past them and reach the load plane. The bridge structure may not project below the support surfaces. The final engineer checks that the bridge is symmetrical about its longitudinal and transverse center lines. They will check that it can be loaded in all 3 possible locations from the top. The 3 loading locations are at the midspan of the bridge and 60 millimeters to either side of center. These 3 locations should be marked clearly 1, 2, and 3 from either end of the bridge by the participant before submission. The horizontal loading plane must be a minimum length of 160 millimeters and centered on the midspan of the bridge. The bridge must have a minimum clearance of 60 millimeters in height above the support surfaces. This clearance also extends 80 millimeters towards either end of the bridge from the center point of the bridge. It coincides with the horizontal loading plane and lies directly beneath it. No part of the bridge structure may be built around this clearance area, and a 60 millimeter high by 160 millimeter wide block must pass clearly under the bridge. If the bridge is marked as disqualified in any of these categories, it will not be tested on the day of the contest and cannot earn any awards. This video does not replace the official rules and regulations, which can be found at the link on the screen.